Hi, everyone. Thanks very much for coming. This is Workflows with Unreal Engine and OpenUSD. My name is Matt Johnson. I'm a technical product manager at Epic Games. Been at the company for about 3.5 years, but I recently transitioned into this role where I focus on our integration of USD into the engine, but also the story for how we use USD in the greater UE ecosystem, and also our participation in the open source USD community. Some quick background on myself. Before joining Epic, was at Pixar Animation Studios for almost 6 years, where I mostly was focused on our software R&D team working on our integration of USD into Autodesk Maya. Before that, I was at DreamWorks Animation for almost 9 years across various different departments in the production pipeline. And so today, I'm very happy to be joined by my colleagues from Sony Pictures Imageworks, Zhonghua Huang, Tsangda Sai, and Dan Ziegler. And I'll reintroduce them a little bit later in the session when we get deeper into the program. So a quick agenda for our session today. I'm going to start with an overview of the current OpenUSD support in Unreal Engine. I'll talk a little bit about the work that we've started for 5.5, things that you'll see in the upcoming release, as well as work we'll continue to carry into the next several releases after that. I'll share some ideas we're considering around how we might revisit or reimagine our OpenUSD support in the future. And then for the main event, Zhonghua, Tsangda, and Dan will give us a behind-the-scenes look at some of the layout workflows that they built out at Sony Pictures Imageworks. And we'll aim to save a little bit of time at the end for any questions that you might have. So getting into the current OpenUSD support in the engine, I think the best way to think of it is the feature set roughly breaks down into 2 categories of functionality. There's the import and export functionality, and then there's the USD Stage Actor and the USD Stage Editor. And I'll dig into each of these in just a little bit more detail. So in terms of import, an asset import is what translates USD prims into Unreal native assets in your project's content folder. And then a level import instantiates those imported assets in an Unreal level. So there are similar features available in the export direction, so for either individual assets or entire levels, though with the caveat that some Unreal asset types might not necessarily be supported, or they might involve a baking process. So for example, materials or landscapes, so that they can be exported and represented as USD. So when importing, we keep track of the source file and prim path that the asset came from, so that you can re-import it from the same location, but otherwise there's no attachment to the original USD. By contrast, USD Stage Actors and the USD Stage Editor provide a more persistent connection to OpenUSD stages. So USD Stage Actors are what expose assets from a translated scene into a level, and USD Stage Editor supports introspection of a USD Stage Actor's stage, as well as some USD-centric operations like loading or unloading payloads. And it also offers some limited editing support for things like attributes and metadata. The important thing to note, though, is that in the current design, the USD Stage Actor sits on top of asset and level import. So as a result, there are a few things you might want to keep in mind when working with USD and Unreal that might feel somewhat different from what you see in other DCCs. So the first is that because loading assets into a stage actor shares most of the same code as import, it also shares most of the same cost. So opening a stage requires a full import, and the entire scene has to be translated before it's usable in the editor. Modifying the USD scene may trigger not only recomposition on the USD side, but potentially also retranslation on the UE side. So this is why we generally advise against doing assembly in the context of a USD stage actor. So that might be where you have USD that you're incrementally building up, for example, using the Python API. And instead, we'd suggest that you assemble the scene and then load it. Assemble the scene in USD, then load that stage into the stage editor. Also, we effectively have 2 representations of the same scene in memory, but in 2 different data models, UE and USD. So we aim to keep the representations in sync. If you make a change to one, we translate it to the other, but we can't necessarily guarantee that that's a fully lossless translation. And again, because of this kind of dual representation of the scene, we have 2 views into the scene data. There's the UE details panel for the UE side and the USD stage editor for the USD side. So it can be a little bit confusing as to where you can or should work. So specifically for 5.5, the focus of our work was on migrating the import functionality to the interchange framework. So if you're not familiar with it, interchange is a new unified system for getting assets into and out of the engine, and it'll provide a more consistent experience across a variety of different file formats. Interchange is what currently provides translation for formats like GLTF, Material X, and FBX, so USD will join those. And interchange offers better customizability for the import process, so you can even use Python or Blueprint to customize the process in addition to C++. And interchange was designed with parallelism and asynchronicity in mind, so we should be able to start taking advantage of that for USD in 5.5 and then take even greater advantage of it in subsequent releases. So for the goal for UE 5.5 was for asset imports of USD using interchange to be at parity with asset imports of FBX. So USD import through interchange will be classified as experimental for 5.5, which you can enable with a console variable and start playing with in that release. The existing integration for import is being refactored so that all of these functionality sets will be leveraging the same underlying code base. And at least for now, the USD stage actor will continue to use what is now the legacy import code base, but we'll transition to interchange once we reach production ready in a later release. Wanted to also highlight this, that we've refocused our efforts on using the common set of open source scenes to help validate and test features and find issues in our integration. So we have an internal team of technical artists that recently completed a pass, the results of which you can see up here. The colors represent roughly how well the artist determined the result in USD in engine to have matched what the scene should look like, whether that's from another DCC, from USD view, or from reference images. The oranges here would indicate that the assets generally imported successfully, but maybe had some minor visual artifacts or other issues, so it doesn't directly match the reference. And then red indicates more serious problems like assets failing to import, or in some cases even crashes. So obviously prioritizing addressing those. And then also wanted to highlight, in working with sample scenes from our partners, including our friends at Sony, we've been able to make some significant improvements performance-wise to the import implementation. In some cases, speeding up the import by 3 to 5 times. I want to caveat that, of course, that it may be highly dependent on the way your scene is constructed. So for example, the prim count, the geometric density, the number or resolution of textures. But we're encouraged by these results, and the more scenes that we can test, the better we can make this. So if you have your own results or even your own data sets that you're able to share with us, we would love to work with you and see those. And again, because USD Stage Actor is based on import, any improvements we make to performance on the import side would indirectly improve USD Stage Actor workflows as well. So beyond 5.5, in subsequent releases, we're going to continue to work on asset and level import and finish off the transition to interchange, eventually reaching production readiness, and then migrate the USD Stage Actor to the interchange-based import and export functionality. Also want to make sure that we have comprehensive export support in addition to import. Everyone has a slightly different idea of what they need exported from the engine. So if you have specific needs, not all, like I mentioned, Unreal asset types can be natively represented in USD. So we'd love to talk with you about that. And finally, migrating to interchange is going to be an important first step in interoperability between USD and UE's new scene graph. So a little bit farther in the future, while the interchange work is underway, we're also talking about how we might revisit the USD Stage Actor to try to address some of the issues I highlighted earlier with the current import-based design. I think the good news here is that there are new technologies both on the USD side and the UE side that we can take advantage of. For the engine, there's the Editor Data Storage System, or TEDS, which is what's being used to integrate the new scene graph data model into the engine. And conceptually, it may be very similar benefit to USD to be able to expose USD-based scene data to engine systems for higher performance and deeper integration. On the USD side, I think Hydra 2.0 is going to be very interesting because it's not necessarily a system that solely feeds renderers as it's been thought of in the past, but can now be thought of as a system that feeds runtimes. So its pluggable architecture might give us a good way to perform the transformations on scene data that we need to be able to bridge USD scene data into engine systems. And finally, continuing to talk about how USD and scene graph interrelate and will interoperate, because that's going to be an important workflow not only for us internally, but for all of our users. USD was kept in mind when designing the new UE scene graph. So some of the features in USD even provided inspiration. So we are hopeful that a lot of concepts may map even more directly than the current actor component model. So that's it for me, and I wanted to reintroduce Jongwon, Sungda, and Dan from Sony Imageworks, and they're going to offer us a look into their USD-based layout workflows at Imageworks.
Hello, everyone. Today, we're going to talk about Unreal Engine pipeline with USD in Sony Pictures Imageworks. My name is Jongwon. I am real-time pipeline supervisor in Sony Pictures Imageworks. My topic is to go over basics of publish from Unreal Engine with USD, starting from why we want to use Unreal Engine layout pipeline and why we want to publish from Unreal Engine and why USD is so important and how we publish from Unreal Engine. And the next presenter, Sungda, is going to explain some of the challenges that we run into, followed by Dan Ziegler's asset pipeline. So we delivered this show. This is one of the series in Love, Death, and Robot. It's a Netflix series. We delivered this show with Unreal Engine very successfully in 2019, and we fell in love with this tool. We thought this tool is best suited for the layout and previs workflow, so we started utilizing this tool into our previs and layout pipeline. So, what is previs and layout? Animation pipeline is a journey to visualize 2D images into 3D content. Apologies for my sloppy drawings, but it is very difficult to know how this 2D image will turn into 3D. So that's why it's very important to have a cheap and easy way to visualize it before we spend a lot of money on the real production. That process is called previs and layout. So this image is good. It has camera compositions and characters, has essential informations in it. But if we place more and more elements into it, we get more information from here. So actually, lightings, depth of field, or FX, more animation tells you a more story from the image. However, in traditional pipeline, we had to compensate some of the expensive features over a performance because we could not achieve both performance and quality at the same time. But in Unreal Engine, we can generate images very close to the final output with minimum amount of effort. So that's why we thought the Unreal Engine is very good tool for previs and layout process. This is an example sequence of the movie Michelle and Machine. This is a rough layout shot done in Maya. And then we decided to recreate the same one in Unreal Engine. You can instantly tell there are more informations in this footage. For example, lighting can tell you the time of the day, effects can tell you the context better, and then even some, it's very basic, but more animation can tell you the beat of the shot. So in general, more elements in the footage gives you more stories. So Unreal Engine is very great, and why we want to publish from Unreal Engine. The answer is simple. We don't want to dispose all the great works we've done in Unreal Engine, and we want to deliver our awesome works to the downstream and then continue working from there. At the moment, we are delivering like cameras and animation down to Maya. We're delivering lightings to Katana, and we're delivering VDV assets to Houdini. And all of that is all those deliveries happening with USD. So why USD is so important? Because it's one unified file type, so it's one unified file type. So we don't need to convert files to many multiple other kind of like file types. So that saves us a lot of effort. And if we choose to USD stage, because it's a reference, we don't need to convert all the assets into static meshes U assets. CG feature animation is a huge project, so that saves us a lot of space. And it's also easy asset update because it's a reference. Also, layering functionality of a USD enables like all the departments to work simultaneously. We can layer all the departments USD into shot USD, and then in any DCC and any time they just load shot USD file, then see all the departments' latest work at any time. That's very handy. So how we publish from Unreal Engine. This is our project structure. So system side of view, we create one show, one Perforce depot per one show. And then, unlike game projects, we create one UA projects per each sequence. There are a couple of reasons for that. I mentioned it, but CG feature animation is a gigantic project. It's sometimes 1.5 hours to 2 hours, containing 40, 50 sequences in it. The structure gets really complex if we contain everything in one project. And most of the CG artists are coming from other DCC backgrounds. So they're not familiar with Perforce, Windows, and sharing projects concept. So we wanted to minimize the possible issues that can be happening by sharing one project among multiple people. And this worked out really well on actual production. And inside Unreal Engine, sequences are represented with persistence level, and shots are, of course, level sequence. And we create some folders inside sequencer, and that defines asset types. I'll show you some example. So this is the example sequencer project. You can see all the shot level sequences are nested as a sub-level sequence under main level sequence. And under the persistence level, which is sequence, there's an environment. Environment lasts throughout the sequence, so we consider it as a level asset or sequence asset. If we expand one of the shot, we created some folders inside it, which defines asset types, and this will later be each department's USD file when we publish. So what happens if we publish that structure? So if we use Unreal Engine's native exporter to publish that structure, it generates USD files per every level, sub-level, level sequence, and sub-level sequences. However, unfortunately, we have to flatten all of them because downstream departments don't have a concept of sub-levels or sub-level sequences. Then we are parsing the flattened USD again based on the frame range. Frame range defines shots, and then also based on the folders that we created, which defines departments, and then we layer all of them in one shot USD file. And then we also layer environment USD file, and this whole set becomes one shot USD. So this is is a very simple example of one shot. You can see there's a shot prim and their asset type prims in USD view. An asset type prim view, asset type prim is coming from Unreal Engine's folder, and all the assets under the folder, you can see it's properly populated under the asset type prim in USD. And asset type prims are, each individual asset type prims are also each USD file layered under shot USD file. And then environment is also exists as a layer. So that's the example of very simple shot. Visual result, they're identical from Unreal Engine to USD view. So the one I showed you was very simple example, but this is a real life example. As you can see, there are more level sequences, sub-level sequences, and if you open these sub-level sequences, sometimes there are more sub-level sequences. This is the beauty of Unreal Engine, but it gives us headache when we are publishing this to downstream with flattened and parsed structure. So we run into a lot of challenges. So I'm going to pass it over to Tsang-Da, and he's going to introduce some of the challenges we ran into as we were developing this pipeline.
Thank you, Chengwang. So my name is Tsang-Da Cai, and I'm a senior software at Sony Imageworks. So today I'm gonna share the challenges we have with the Unreal Engine and OpenUSD. I have to really I do appreciate Epic has been giving us a lot of support, and their USD developers have been working closely with us and giving us a lot of support. So I'm pretty sure what Matt mentioned was really true. So in Fab 5, we will see something really great for USD. So the challenges we ran into, the first one is reading textures from Linux to Windows through Linux symlinks. And the second one is to export the transforms in workspace to USD. And there are some edge cases that would take over 8 hours to export a complex sequence to USD. And we couldn't animate visibilities of children actors in level sequences. And the last one is to save and load Unreal materials and change the properties, for instance, the USD prims. Regarding reading textures to Windows through Linux symlinks, our legacy pipeline is built on Linux, so we need a solution to read textures from Linux to Windows through Linux symlinks. Yeah, well, we cannot just tell the production, hey, we are abandoning Linux and start to use Windows. So, and we also needed to make it work for our USD asset resolver. So it's not only for textures. We need a flexible way to make symlinks work for Windows and then make it work in Unreal Engine. So we can use this Windows API to check if a folder or a file is a symlink or not. And then we can resolve the paths from them. And next, we can either implement an operation in our custom plugin, or we can register a custom UE broadcast callback, and then we put that function inside here in the source code, in this function of this CPP. So this will automatically solve the textures for the file formats like Alembic or FBX. So here we see an example why we needed to export transforms in workspace. if we play into an attached section, we see here the hierarchy in the outliner get changed. So we don't want to limit the freedom for the artist to use attached section. That's why we have to export everything in world space. So our solution is to first add a new option to USD export options. And this is called Compute World Transform. And here, this part is the original code. And here, we can call this get component transform to get the world transform in world space. And there are some edge cases like camera, rig, real actor. We have to force updating them by ticking this actor to get the correct transform. And next one is there are some real sequences that took over 8 hours to export, in which there are like hundreds of channels and tracks for thousands of frames. So if we see something wrong in that case, and then we will need to wait for another 8 hours, meaning another day, to change something. So our solution is to create a new option in the USD export option, and that only exports animated values. And that's simply comparing the current value, the values of current frame, and if that is different from the value of previous frame, then we write it out. And they are not keyframes, so with this way, we basically don't have to worry about the animation curve mode, something like if it's linear or cubic. And we managed to reduce the time from 8 hours to 30 minutes. So this is a simple example. We can see the transform after frame 4 are all the same. So we don't need to export all of them. We just need to export what is different. And next one is Unreal doesn't allow us to show high the children actors in level sequences. And so here is an example. If we set the visibility to off for a parent actor, we still see its children in the viewport. And our solution is to create a new component, and in which we can indicate the print paths to the parent actors. And we can choose the USD stage actor, which we would like to control. And then we can iterate the children of the parent actors to toggle their visibilities. So here's an example. And the last one is to save and load Unreal materials and change the properties, for instance, the USD prints. When we create USD Unreal actors, that will be Unreal will dynamically create those actors. So that being said, that doesn't allow us to save the changed properties and the materials. For instance, the prints. And also, we tried to save them as USD attributes, but it's inevitably to somehow refresh the USD stage in Unreal. And for some of our real environment, it's really heavy. So even just to refresh part of that would take maybe 5 minutes. So our solution is to create another actor to save the materials in this format. We see this is print path and the paths to the material. And we do something similar to change the properties. So here we see a print path and the path to the changed properties. So, and then we can trigger this actor after loading a label, so everything will be automatically restored to the actors and the components. And we save that in just simple text file, so we can simply migrate the setup between labels and Unreal projects. Next, I'm gonna hand over this to Dan.
Thanks, Sangda. So I'm Dan Ziegler. I'm the pipeline architect for modeling and layout departments at Sony Pictures Imageworks. I have over 20 years experience in VFX, but I'm still quite new to Unreal. And I wanted to talk about how we set up our USD assets and how we integrated them into Unreal Engine for the purpose of our layout pipeline. So first, I'll give you an overview of our asset structure and some of the challenges that we faced adapting it to work for our Linux-based studio pipeline to integrate it into our Windows-based Unreal pipeline. So Jongwon already mentioned that our previous exploration with Unreal was this short film that we did for Netflix called In Vaulted Halls Entombed. And that project was done basically entirely in Unreal except for the modeling and animation. So we modeled in Maya, animated in Maya, brought that into Unreal Engine as FBX, and did all the lighting, scene assembly, cameras in Unreal. And that worked great, but we knew that it wasn't what we were going to do for our layout pipeline because we had to get data not only into Unreal, but we also had to get it back out again into Maya and other DCCs for the downstream departments. So we decided that instead of using FBX as an intermediary format, we were going to use something that would work for both import and export, and we decided on USD. Like many studios, we're interested in adopting USD across our pipeline as it provides a common scene file format that we can use to exchange data between different DCCs, as well as with external studios. However, there's not really a guide as to exactly how to implement USD, so it's kind of up to the user to figure out how to structure your assets and your scenes, etc. So we decided to make our USD asset structure to mirror our existing pipeline as closely as possible. For years before USD was even created, we've been using our own proprietary system called Assembly Component. In our system, assemblies are basically hierarchies that reference other assemblies or components. Components represent the base level of an asset, usually a geometry cache, which can be instanced. Luckily for us, USD has a very similar concept of assemblies and components, so we were able to use this structure for our assets. I mean, the backbone of a VFX pipeline is really the ability to version control assets and reference those versions. So at Imageworks, we have a proprietary database called VNP that we use to version our data. Our system uses URIs to reference data locations instead of requiring the absolute paths. So the only thing that we're storing in the database is essentially the path to the asset, not the binary data. So the URI gives us the flexibility to use floating version tags like current or approved instead of specific numbers, if desired. VNP is used heavily in our current asset pipeline, and we knew we'd need to use it in our USD pipeline as well. So to do this, we wrote an asset resolver that worked inside USD. Because we were working in Windows for Unreal, we needed to port that asset resolver and the VNP client code to Windows. I think Sangda mentioned that. Using the asset resolver, we were able to keep assets up to date with the current version automatically. We also wrote a custom importer for Unreal to add our assets onto the USD shot stage as references. This made it straightforward for the layout artist to find assets in our system and to add them into the correct layer for our shot template. We can control the variation at import time to choose between high-res geometry, low-res proxies, or bounding boxes. Having proxy geometry level of details available as variants was another important feature of our asset pipeline. We found that assemblies with many child assets can be slow to evaluate in Unreal. Basically, the more actors you generate, the slower things tend to get. So in those cases, we used proxy representations to cut down on the amount of actors. We also made use of the point instancer feature of USD to represent complex environments. So if you bring a point instancer into Unreal, it turns it into a instance static mesh array. So that was a good optimization for us. For cases where the layout artist needed to modify the asset directly in Unreal, we added the ability to import the USD geometry as Unreal static meshes. Importing it as static meshes, broke the connection to the original USD, but we had metadata on the asset so we could figure out where it came from if we needed to find our way back. So here's just an example of our USD stage in Unreal. I think Jongwon already showed a more complex example, but this is just showing an asset that's been imported under the E and V prim. So we organize our shot structure by sort of the asset type. And so here we've just imported something under E and V. The asset, and we also use these, we take advantage of USD layers for edits. So we import assets onto what we call the staging layer. But then if people do edits to those assets, like move them around, scale them, whatever, that would all go on the set dress layer. And we made a layer called view that would just be for temporary edits that we knew we didn't want to actually publish. So when we were working with USD and Unreal, we found a few settings that helped optimize our workflow. We found it was important to tag geometry as kinds. So tagging geometry as components or assemblies allowed us to collapse to specific levels and avoided generating too many actors. Nanite was really useful because it allowed us to load our high-res geometry and still have real-time speed in the viewport. We did not need to make, optimized LODs just to work in Unreal because we were able to use the same assets that we're going to render in our movie. Though we do have proxies as part of our system already, just in case we need them. But basically, we were able to work with our movie assets in the viewport. For more complex sets, we used point instancers, though they're harder for artists to manipulate because you can't easily move the instances around. But we did use them for backgrounds where there was a lot of heavy geometry, city building blocks of whole cities, that kind of thing. We also made some custom scripted actor actions. And those were just to give us some tools that didn't work particularly well with our references. So the ability to copy and paste and duplicate prims and preserving them as references. So we made shortcuts for the artists so they could do that easily. And we also made a scripted actor action so that they could easily display the metadata if they want to know what their asset, where it came from. So there was some pros and cons to using Unreal for us. I think the pros outweighed the cons, but still I get to talk about them. So being able to use the same assets across our pipeline was a big advantage. We were able to use these USD assets. We didn't have to create Unreal-specific versions of any of it. Using our asset resolver system, we were able to keep projects up to date with the latest versions. And since the USD data, like the actual references of the assets, lived outside of the project file, our projects were small and they saved quickly. We did have some challenges. One of our challenges was slowness refreshing the USD stage. If you make changes to a USD stage and it has to reevaluate it, it can take quite a while to regenerate the actors. Another challenge that I think Sungda mentioned that we had to work around was if you make edits using the Unreal tools to a USD asset that's coming sourced from a USD stage actor, you will basically lose those edits once the stage reloads. So we had to figure out ways to do certain things that were to preserve, Unreal specific assignments like material assignments, that kind of thing. Playback of animated USD caches was slow, so we ended up sticking with Alembic for animated cache geometry. Specifically, skeletal mesh Alembic seemed to be the most efficient for us. And in some cases, artists did opt to still use the static mesh workflow because they simply wanted to be able to work with things really quickly and have more flexibility. But even in those cases, because we had that metadata tagged on all the assets, we could still figure out what the real asset was that they had started with. And lastly, there's just a couple of statements from artists who got a chance to work with this pipeline and sort of testimonials as to how much they preferred it to our legacy pipeline that we've been using for years. And I think that's all I got. I want to really thank Epic for inviting us to do this presentation. We really appreciate it.